All right, 7.1 part 2. Now that we know what a monomial is, and how to find its degree, we're going to combine monomials to come up with polynomials. Poly, the prefix poly means many. Okay, so what a polynomial is usually many monomials added together. So usually it is either a single monomial or some. Oh, that does not look like an R. Or some. Sorry. Which is addition of monomials. And since we know that addition can be written, subtraction can be written as addition, okay, subtractions work there too. It's the sum or the addition of monomials. For example, okay, if I was to take our monomials from up here, I don't know, our 10 from up here is a monomial and add the 3x to it. 10 plus 3x. This is not a monomial, but it is a polynomial because I'm taking two monomials and adding them. Okay. And since it's only got two of them, we call it a binomial. Bi, oh, that's not what I want on highlighter. Bi means two. That prefix means two. So a binomial has two terms or two monomials. So this is really just meaning two monomials being added together. So that 10 plus 3x was a binomial. 5x plus 2 is a binomial. 1/2 xy plus z is a binomial. Or even if this was a minus z, because we know this can be written as plus and negative. Okay, so that is still a binomial, bi meaning two. So if there's two terms, it's a binomial. If there's three terms, we call it a trinomial because tri means three. Just like a tricycle has three wheels, a tripod has three legs. So tri means three, so three monomials. So when I add three of them together, for example, x to the second plus 5x plus 2, we have three separate monomials, an x squared, a 5x, and a 2, and we're adding them all together. Now determine the degree of the polynomial. We look at the degree of the monomials, and it's the greatest degree. It's the greatest degree of its terms. Again, terms is just another word for monomial. Monomial can be a mouthful sometimes, so we tend to use the word terms a lot, but it is the greatest degree of its terms. For example, this trinomial over here. The degree of this monomial is 2, because there's two x's. It would be x times x. So the degree of this one is 2. The degree of this one is just 1, because it just has that single 1x. The degree of this last one is 0. So the degree of this whole polynomial is 2. Since that's the biggest degree of all its terms. Okay. So it's the biggest degree in all its terms. Okay. We like to be able to compare polynomials, and it can kind of get confusing if we're all writing them in different orders. Like if I was to write this in a different order, like maybe put the 2 first and then the x squared and then the 5x, because we know we can add in any order. So we have something called standard form. It's really just a way to easily compare polynomials. It's in standard form when the exponents decrease from left to right. Meaning we want the biggest degree comes first. Another way of saying that is biggest degree comes first. Okay. Like in this one here, we have the one with degree 2 comes first, and then degree 1 next, and then no degree. So this here, this guy right here, is not in standard form. We would have to rewrite it in standard form. Okay. And then our last thing is the leading coefficient. The coefficient is the number first of all, the coefficient is the number being multiplied in the term. All right, so I'm going to switch here. I'm going to switch colors to green, and we're going to go back up into some of our previous terms and try to find the coefficients. So the coefficient, okay, of this one here, this 10, the coefficient of this 10, there wouldn't be one because there's no x, or we would say it was just the 10. We normally don't use the word coefficient in that term because it's just this is what we would call a constant term because there's no variable in it. A constant term has no variable. So therefore it has no coefficient. But this 3x, the coefficient here is 3. The coefficient is just the 3, that number part. And this 1/2 ab squared, the coefficient in that is the 1/2. Okay. In this 1/3 n, the coefficient is the 1/3. In this negative 1.8 m to the 5th, the coefficient is that 1, negative 1.8. Okay, so here, if we're looking at 5x squared, the coefficient is 5. Okay, so when we talk about the leading coefficient is the coefficient of the first term. Okay, so the leading coefficient is the coefficient of first term. Okay, when in standard form. So once we get it in standard form, that leading coefficient is that number in front. If there is no number in front, like in this trinomial here, sorry, iPad's being glitchy. In this trinomial here, we have x squared plus 5x plus 2. We like to assume there's a 1 in front of here, so the leading coefficient on this guy would be the 1. There is our leading coefficient. I'm going to write it this that way. The leading coefficient there is that 1. Okay, so here they give us a polynomial. We want to write 15x minus x to the third plus 3. Very first thing I'm going to do, and many of you do not do this yet, I'm going to come in and I'm going to write the subtract as adding a negative. So that negative is attached to that term. I can tell here that it's got 3 terms. 1, 2, 3. Because I'm adding 3 things. It wants us to write it in standard form, identify the degree and leading coefficient. Well, to write it in standard form, I need to talk about the degree of each term. How many variables does each have? Well, this first term only has 1x, so degree 1. This second one has 3 x's because of that x to the third, so there's 3 of them there, so that would be degree 3. This one doesn't have any, so that would be degree 0. So we would want to put that negative x to the third first. See why it's important we attach that negative to it? We would have missed that. And then that 15x is positive. That would go next because that's got a term of 1 and then plus 3. So we have it written there in standard form. Our coefficients decrease. This first one's got our exponents. This first one has an exponent of 3. This next one has an exponent of 1, which we just normally write the 1, but it is a 1. And this next one has an exponent of 0. It doesn't have any x. So it's in standard form. Identify the degree. Well, we determine the degree of each one, 1, 3, and 0. So that tells me this is degree 3. Because the biggest of those is 3. It's degree 3. I'm even going to go this one step further and I'm going to write down. This is a trinomial. It's got 3 terms. So it's a trinomial. Identify the degree and leading coefficient. The leading coefficient here would be the number in front of that very first term. Well, the number being multiplied there, well, we don't have anything, so when there's nothing there, it's a 1. So negative 1 is my leading coefficient. Okay. All right, so we wrote it in standard form. So there's it in standard form right there. The degree is 3, and the leading coefficient is negative 1. And we even took it one step further and said it's a trinomial. Okay. So these next ones, write each polynomial in standard form. Well, this first one, it's just a single term. Standard form, there, done. Okay, not much else I have to do with it. It says to identify the degree. Well, since this only has 1 term, it would be the degree of this. So the degree is 4. So we'd say degree is 4. Okay. Identify the degree and classify each polynomial by the number of terms. Well, how many terms does this have? This only has one term. So that would make it just a straight up monomial. Mono meaning one. Okay, mono means one. Okay, we didn't talk about that at the beginning, I guess. All right, next one. Okay, we want to put it in order. So first thing I'm going to do is I'm going to again attach this negative to the x. So this first one is degree 0. This one's degree 2. This one's degree 1. So I'm going to put the 5x squared first because we want the biggest exponent first. And then the minus x next, and then the plus 4 last. Okay. The degree on this would be 2 because of that x squared. And 1, 2, 3 terms, that tells me it is a trinomial. Because 1, 2, 3 terms. Next one, well, we have a q to the 5th. We need to put that one first. Plus 8q. Okay, this is degree 5. This is only degree 1. There's only one, so this entire polynomial degree is 5. And it has 2 terms, 1, 2, which makes it a binomial. I don't believe this asks for a leading coefficient. Identify the degree and classify each. Yep. All right, next. Page 362, 14 through 22 even. Again, I want you to do it at Big Ideas Online.